Hey guys, welcome back. We're continuing our study of transformations and looking in reflections today. So notice with this beautiful image we have here, everything that's on the top of this line here is being reflected in the water below the line. Okay, so all these points here, A, B, and C, their reflections are found on the other side of the line. So going directly down here from A to A prime would be the reflection of A across this axis or this line here, and then B is being reflected across that axis down here to B prime, which would be the image of the reflection across the axis, and then C is being reflected right here to the point here, the summit in the water. Okay, so everything, all the points, those are just three that we picked out, are all going to be reflected across that line. So reflection, let's look at the reflection across the y-axis. So we're going to take this A, B, and C here, and we're going to reflect it over here to A prime, B prime, C prime, or triangle ABC. The image is the pre-image, and the image of the reflection of triangle ABC is the triangle ABC prime. So let's take this point up here, A. It looks like it's going to go 5, a distance of 5 to the axis here, and then if we go 5 to the axis, we have to go 5 beyond it as well in the reflection. So one thing we'll notice with the reflections that whatever distance we go to the axis is the same distance that we have to go past it in the reflection. Okay. All right. So we went from the point 5, 3 to now the point negative 5, 3. So two things to notice. The first thing is that if we go from 5 over to the axis, then we go 5 beyond it. Now it's going to become a negative 5 for the x value when we reflect it across the y-axis here. And then the y value actually stays the same. So the 3 and the 3 is exactly the same. So our rule for reflecting across the y-axis is that our x values become opposite and the y values remain the same. Okay, so what about reflecting across the x-axis, like the axis we have down here? Well, now we go from 5, 3, and we go down. So we're going to go, down 3, and then we go beyond that 3 as well. So now it's going to be 5, negative 3. So notice the x values stay the same, and the only thing that's changing now is the y values become opposite. So our general rule would be, I should fix that, it bothers me, would be x and y turns into, after the transformation, which in this case is a reflection, would become x and opposite y. So if it was positive, now it's negative. If it was negative, now it's positive. All right, so let's reflect the point just in review. Reflect the point A, which is 4, 2, across the x and the y-axis. So across the x-axis, that's going to go down 2, so then down 2 more is going to be 4, negative 2. So the image of that would be the point 4, negative 2. Okay, and then reflecting across the y-axis here, looks like we're going over 4, so we go over 4 more to negative 4, so that's going to be this point right here, and that's going to be A prime is negative 4, positive 2. And then here I'm doing A double prime just to say that it's a different image of a different transformation. Usually we will add more and more as we go, so we would start out with A prime, then we do 2 primes, and then 3, and keep going. Anyway, so if it's over the x-axis, the x stays the same, the y becomes opposite. If we reflect over the y-axis, the y stays the same and the x becomes opposite. All right, and if you ever forget, you can always graph points out like we did here. That's what I would recommend on the test. Okay, so that was it. Wow, that was a sub 4-minute lesson. How awesome. Each point is reflected across the line indicated. Graph and find the coordinates of each image. So we want to find the image of A across the y-axis, reflected across the y-axis. So here's our y-axis here. We want to move A over here somewhere. So the point is negative 2, 1. So if we go 2 over, then we got to go 2 more, which, oops, wrong one. Spoilers, which is going to put it at right here. So A prime, the image of A reflected across the y-axis is going to be point positive 2, 1. So it went from negative 2, 1 to positive 2, 1, which is right over there. And then B reflected across the x-axis. So we go down to the x-axis, then we go 2, then we go 2 more, which is going to go from the point 1, 2 to now 1, negative 2, and that's going to be our B prime. You can do that for the rest of the points. Pretty simple there. And you got your answer bank for the first 6 questions. Graph the reflection of triangle MNO and ABCD across x and the y-axis. So this one's going to take a while, but it's kind of fun because you get to graph it out and you kind of see visually if you did it right. So we're going to move M and O across the x-axis first. So our x-axis is here. And so O is up 2, so we're going to move it down 2, which puts it right here. So this is going to be our point for O prime. And then N is up 4, is at 4, 4, so it's going to be now 4, negative 4, which would be right there. And then up 3, so we go down 3, which is at the point 3, negative 3. And then you can fill in the rest here. So this is going to be MNO prime, so triangle MNO prime. And then we're going to reflect it across the y-axis. So this is 3, 3, so now it's going to be negative 3, 3. And then 4, 4 is going to be negative 4, 4. And then 6, 2 is now negative 6, 2. Okay, so there's OMN double prime, okay, or MNO double prime, and reflect across the x and y. Okay, do the same thing here, so it's going to be up 1 there, and there's 2, so it goes there. This one is 3, so it goes to here. It's the exact same point as M double prime, and then 3, then up to 3 as well again. Okay, then you can graph that out. Okay, cool. Same thing here, we're going to reflect it over 1. This one goes 3 to positive 3, and then 4 to negative 4 to positive 4, and then that point's exactly the same thing as B is that point, so we can graph that out. Okay, cool. And another thing that's kind of interesting here, if we look, is that this image here and this image here, the two reflections, they're actually rotated 180 degrees. So this is a rotation of 180 degrees, and it doesn't matter if it's going to be clockwise or counterclockwise because we're doing 180 degrees. So this point here and this point here and all the other points are being rotated 180 degrees, which is really cool. We'll look at rotations for 90 degrees and 180 degrees, those rules. That'll be the next thing that we do. We'll do that lesson in person. Unless you were meeting on Tuesday in 4th hour, then you'll have to do that lesson online because we lost a day from the snow day, but that's okay. All right, number 8, draw each figure's reflection image of the reflection across the dotted line. I don't like how that's worded. So basically, just try to draw the reflection, so mirror whatever's going on up here, down there. What I would suggest is take your vertices and then plot those points. So I'm estimating that's going to be somewhere about right here, okay? And this point's going to be about right there. Then this one is about somewhere over the rainbow. Oh, there it is. Okay, cool. So just estimate those points and then connect the dots, and that will give you the image of your reflection, which I think it looks something like that. That's not too far off. This one's a little bit off. It should be somewhere closer, about right there. But that's okay. It doesn't have to be perfect, but it does. All right, number 12. Given triangle STV, perform the following composition of reflections upon STV. Compare the STV double prime. Okay, cool. So the x-axis, then the y-axis. So first we're going to reflect it across the x-axis. So S, T, and V. So S is going to go 2, and then we're going to go up 2 past that, which would be this point here. T is going to go 1, and then V is 4, negative 4 to 4, 4, which is right there. Okay, so that's STV prime. And then now reflect it. This is a composite reflection, so we're going to do 2 reflections. So take the reflected images and reflect that across the y-axis. So that's going to be right there. T, 4, 1 is going to be negative 4, 1. And then 4, 4 is going to be negative 4, 4. And that's going to be STV double prime. If you notice, there's actually, whenever we do it that way, it's going to be a rotation of 180 degrees as well, which is kind of cool. So when we switch the order, when we negate both of them, like opposite x and opposite y, because this point went from 4, negative 4, and now it's going to be negative 4, positive 4, so we just switch the sign for the x and the y. That's a rotation of 180 degrees. All right, 16. What's the rule for reflections across the x-axis? Well, if you forgot, whenever we reflect across the x-axis, we go down 2, then we go down 2 more, which makes it the point A double prime, which is 4, negative 2. So the x value stays the same, and we change the y to the opposite. All right, so now we're going to apply that rule to reflect triangle FGH across the x-axis. So let's start with F. So F is negative 1, 3, and so that's going to become negative 1, negative 3. So negative 1, negative 3, which would be this point right down here. And then negative 5, 1 becomes negative 5, negative 1. So that's going to be this point right here, which would be our G prime. and this one was our f prime. Okay, and then h is 4, 0. That's going to become 4, negative 0, which is still just 4, 0. It's the same exact point. It didn't move at all, really. And then we can connect our lines. So connect the lines going across there, and that should be it, pretty much. Oh, by the way, this looks to me like an alligator. I don't know if you can see it, but this is definitely an alligator, and here's his body, and he has this tail here, and the little legs, which looks like he's on a skateboard, but no, he's actually, now he's on a skateboard. It's absolutely terrible. And this is a skater gator, in case you're wondering. Yes, that is the skater gator.